Okay. Okay. Good afternoon to everybody. We are going to start this EcoSource seminar series with Eduardo Hernández-Rodríguez. Eduardo Hernández-Rodríguez is a PhD candidate in Utrecht University from the Netherlands in the field of economic geography. He's also a Marie Curie Fellow as an early stage researcher within the Polis ITN. That is a project, a European project for PhD students funded by European Union. And previously he was a fellow at the Innovation Economics Division, Department of Economics and Statistics at the World Intellectual Property Organization, the WIPO, in Geneva, in Switzerland. And he is graduated from the College of Europe in Bruges, Belgium, with a Master in Social Science in European Economic Studies, European Law and Economic Analysis. And he also holds a bachelor degree in Economics and Law from the University of Seville. And well, it's a pleasure to welcome you here at the EcoSource Seminar Series at the Rovira Virgili University. So you have 40-45 minutes to present your research. This research that is entitled Technological Diversification through Global Value Chains. So thank you very much, Eduardo, and the floor is yours.
Thank you very much, Carles, and also José María for the invitation, and Eulalia for the great organization. For me, it's really a pleasure to be here to share with you this project I've been working lately on technological diversification through GVCs, particularly trying to use an evolutionary model of technological diversification, including interregional linkages, in this case, global value chains. This is part of a bigger project that I'm developing with some colleagues in the Netherlands, like Ron Boschma, Andrea Morrison, and Shan Yeyem. Although in this case, it's actually a solo author paper by myself. So let me start. Oh, by the way, like you can just interrupt me whenever you feel like you want to ask something. Otherwise, we also will have some time at the end. I will try to keep it on time so we can have time to discuss afterwards. So let me start from the very beginning. A little bit about the motivation and why about this project. So, as we all might know, like innovation really concentrates in space. Like we have cities, we have regions that are highly innovative, while other regions and other cities really struggle to actually innovate and develop new technologies. For example, in the case of Spain, right, we are now in Catalonia, which is a very innovative region, where we have other ones in Spain, like they are really struggling with this. So the purpose of a lot of industrial innovation policy, like a smart specialization in the case of the European Union, is try to actually enhance the chances of regions to actually develop new technologies. And in that sense, there is a long literature and a long existing tradition within economic geography, and particularly evolutionary economic geography, which is the kind of approach we use in Utrecht University, about how regions diversify in technologies over time. The emphasis has been put into local capabilities, so basically what regions already do really matter for the future evolution of technology. So we don't expect, like, I don't know, in the middle of nowhere we will get a new Silicon Valley, but basically you have a diversification process in which you will move into more complex technologies and develop new technologies over time. So this is a little bit of this idea that it's not really working this policy about cathedral in the desert. So in the middle of nowhere with no local capabilities, it will be really difficult to you to just create new technologies. However, in parallel, we also have a lot of literature basically working on what we call interregional or maybe international linkages that can take several forms. You have like from multinational enterprises, FDI, migrant, global value chains, or scientific collaboration as a way to acquire non-local knowledge into the region. Like for example, as a very simple example, when we collaborate with co-author in other university, it may be because we have different expertise in a way. So I'm really good doing, let's say, evolutionary kind of things, but then we have Carles that is really good doing spatial econometrics, and then we have Maria using interregional input-output, for example. So then we can combine our three different expertise to actually produce a paper that we probably cannot produce on our own because we need different kind of knowledge to produce. So this is something similar here. Like for example, migrants can actually move from region to region, producing or providing new knowledge to the region that is not local. Multinational enterprise can set up a new, let's say, factory or headquarter plants in a different region that can actually bring in new knowledge that was not existing in the region, and that can actually trigger innovation process and knowledge exchange in these regions. However, what is actually missing in the literature is, okay, to incorporate these interregional linkages in the kind of evolutionary model of technological diversification. Because as I said, we have been looking too much inside the region. So we have been saying regions, you have to diversify into these technologies because you are already doing this kind of stuff, so it will be easy to you to actually move there. But however, like, it might be important to actually acknowledge that there is non-local knowledge that can be actually put in place and can actually help regions to diversify over time into new technologies and avoid, let's say, lock-ins kind of situation. So what we want to do with this paper is, first of all, as I was saying, trying to integrate this literature on local capabilities and non-local capabilities, so basically evolutionary economic geography and global value chains in particular, that we'll have a look more into detail soon. And basically answer these three broad research questions, like what is the role of GVC, global value chains, participation for regional technological diversification? So basically, if regions engage in such a new form of international trade, they might be more likely to diversify into new technologies. We also want to understand if there are differences between backward participation and forward participation in the value chain. I will explain more in detail what I mean by this. But basically, to put it simple, regions participate in global value chains in very different ways. They can be at the beginning of the chain, at the end of the chain, they can be at the buyer side, in the seller side. So this difference in the way they engage in value chains might also have implications for the technological evolution of the region. And then we also want to check if this participation in value chains benefit all regions in the same way. Because we will see in the literature from GVC that GVC might be an opportunity for lagging regions or less developed countries to actually get this knowledge that is not present in the territory but can be important for them and so can be useful to trigger these technological diversification dynamics. So let me have a look very quickly to this, let's say the basic notions that are really relevant here. I was saying, and I was mentioned already, like that we have put a lot of emphasis on local capabilities, and this has been translated into the literature. Okay, we started with all this debate on related and related variety, and was translated in what is now called the principle of relatedness, which basically the idea is that when you diversify over time, whatever it is in products, industry, exports, patents, trademarks, you usually tend to diversify into related things. So basically, as I said before, if you are producing now motorbikes, it will be easier to you to diversify and start producing cars. But if you are producing tables, it might be very difficult for you to start producing cars because they are really different products. So then you go through this kind of step-by-step diversification process in which is the related kind of variety what really matters. And this can be measured, we will see in a moment, using some techniques. But again, this is always looking to the region. So, as I said, what you produce now is important for what you will produce in the future. But I was mentioned already, like, we are not taking into account the interregional linkages. And particularly in the European Union, which is the case I will present here, we have many interactions between regions, right? Not only at the national level, but broadly in the European Union. We have the internal market, so in the sense of production and input-output relationship, we have really a lot of trade between regions. So the regions are trading between each other, and this can actually rise to have some opportunities to learn from one each other. As I said, the role of interregional linkage is too broad, like from migrants, FDI, multinational. In this case, we will focus on global value chains, which has been very little interaction with evolutionary economic geography. Particularly, there have been two different strands of the literature that kind of have developed in parallel, so they don't really interact with each other, although there is some notions that are really common, let's say, there is common ground between the two different strands, like from absorptive capacity kind of notions to also the role of related knowledge, as I was saying. So basically what we see is that has been very few attempts to integrate this role of interregional linkages into evolutionary models of technological diversification. However, as I was saying, the literature has really provided us with a lot of interesting knowledge about global value chains and its impact, let's say, as a knowledge pipeline connecting different countries, different regions, or different areas. So there is a strong literature suggesting that global value chains can act as an exogenous source of knowledge or as a source of exogenous knowledge that can provide these non-local capabilities that can be useful for regions. And that the idea of global value chains at the end is about that. So we are now in an international trade setting in which a country or region is not really producing the whole product, but it's basically different production stages that are split across territories, and by adding some inputs and recombining those inputs, we are able to get the final product. So we are not in this setting anymore of made in China, basically, that everything was produced within one country, and now, for example, if you take an iPhone, several pieces, the software, the assembling, the after-sales service is produced in different places. This can help regions to access this non-local knowledge that, okay, I cannot maybe produce the software of an iPhone, but I can do some assembling, and by assembling and doing some recombination of these pieces, I can actually learn something new. So this is actually the way in which global value chains can trigger knowledge exchange and spur innovation. However, in this sense, and also really similar what has been suggested in international trade with the scholars like, I don't know, back to Grossman, Helpman, importing and exporting can be also a way to actually innovate and trigger technological change. And in this sense, the direction, let's say, of trade really makes a difference. So it's not the same to actually import goods or export goods. The evidence suggests that it's by importing something that has been produced by others and recombining it to produce your own export, the way this knowledge exchange can be produced. Also, because if you are just producing and exporting these things that has been produced by your own in your own region, you are not learning anything, let's say, from anyone, because it's just things that you do. Okay, you can already do it, so you can actually starting on triggering new knowledge. But if you import that, so if you import value added, you can actually maybe learn something produced by third. Yeah.
There's this developer stuff which is learning by exporting. It's also good.
Yeah, which is also a channel. And we will see some nice interesting results, which I should also acknowledge. Not only that, but also which also suggested by the literature in innovation, more about learning from, let's say, the user and proximity to user, right? That is much closer. You are at the seller side of the value chain. That can be also seen. We will see some results that I also get in that sense that can be done. But still, I still think that in this case, the big push will be from importing rather than exporting. However, I really acknowledge that.
I'm a bit confused because it says theoretical framework, but what is a theoretical framework?
What do you mean exactly?
What are the equations?
Well, I will have the model. I don't have a theoretical model in that sense. So it's more a kind of literature review, if you want to call it like that.
Okay.
Yeah. So I'm not really doing theory. I will more apply it, and I will see the analysis afterwards. I call it theoretical framework, but if you prefer something like literature review, will be more feasible here.
Okay. I'm just trying to understand, like, how are you going to combine all of these things together? Because otherwise, it's kind of hard for me to know what to do.
Yeah. Maybe it's clear when I show you the econometric equation, right, and all the variables that will be included. Just to have an impression of the story I am trying to make. So, corresponding to the research question I was just mentioning before, and matching them maybe with some hypothesis, what I will expect from this literature review shortly introduced. First of all, I will expect that regions that participate in global value chains by being exposed to more exogenous knowledge. So then regions that participate in this international trade might be more likely to experience technological diversification over time. Second, I will expect that it is backward participation. So as I was saying, maybe more regions that import value added from others or import inputs from other regions and then recombine them to produce domestic gross export might be the ones that have more chances of technological diversification over time. And then, as I was said before, I mean, I think I skipped it, but I want to make the point again, that the level of economic development of territories also matters in the sense that, as I was saying, non-local capabilities might be more relevant for, let's say, lagging regions or less developed regions, since they might be less likely to have strong capabilities already present in the territory. So, a point, if you want to translate, maybe in the case of Catalonia, which is already a technological leading region, might be less important to actually be in this kind of network since they already have strong capabilities, and this might be more important for other less developed regions or more peripheral regions. So then I will expect, in hypothesis 3, that this importance of global value chains participation is more relevant for less developed regions than for more developed regions in the sense of technological diversification. So that's all is great, or what I want to do. Let's have a look into the different data, variables, and econometric setting I'm using. Regarding data, I'm mainly using two different sources of data. First one are interregional input-output tables, which is in this case EU region. That was produced by some colleagues of us in the Netherlands, like Marcel, Mark Thiessen, Frank van Oort, Bart Loos, Dario Deodato. And it includes input-output flows for 249 EU regions, coming from 24 different EU countries. And also it has data on 16 non-European countries and a world section. Has some issues, which is that it's just concentrated for 14 industries, which is quite aggregated. We have some manufacturing industries, construction, but also it includes, let's say, touristic industry, hotels and restaurants in the sense, like financial intermediation, telecommunication, logistics, this kind of stuff. And it's only available for 11 years, so from 2000 to 2010. Using this, we will compute the different metrics of global value chain participation that we will use at the regional level. And then I was talking about technological diversification, however, and innovation, but the problem with innovation is that it cannot be directly measured. So you cannot just say, okay, here we have in the first row an innovation, let's talk with him. We have to proxy it. And the way we proxy innovation, in this case, and technological diversification, I will explain, is using patent data. In this case, we use the database provided by OECD, REGPAT, which includes patent applications to the European Patent Office from 1977 to 2021, because I'm using the 2022 edition. The patents are matching to regions based on the address of the inventor. So if an inventor registered in a patent is living, let's say, in Reus, it can be matched to the province of Tarragona. And then they are also classified into what is called IPC codes, which are technological classes. We use 4-digit IPC codes, which will include then 650 different technological classes.
Just understand,
yeah.
Sometimes there are multiple inventors
right.
for a patent.
Yeah.
How do you handle that?
Then you can do two things. One could be to use total count of patents, so it will count as one for every region, let's say. Or you can use fractional count of patent, which will be just to, if a patent has 3 inventors in 3 different regions, you can just divide 1 by 3, and then you count it as 0.33. I'm using this one, this latest method, because I think it reflects better the real contribution. But this is also something that really doesn't change the result, but you can do. The same happens with the IPC code. Each technology applies to different kind of technologies. Each patents apply to different kind of technology. So you can have a patent that is for producing glass stuff, but can be also organic chemistry to be applied to the aluminum, for example. So then you have every patent can be also distributed into the different IPC codes. And then for the data on controls variables, I use Eurostat, and for the case of the UK, the Office for National Statistics. Okay, let's start from the part of technological diversification, which will be the dependent variable in the model. We use a very standard method in economic geography, let's say, which is no more than a Revel comparative advantage, Balassa index, location quotient, or in this case we call it Revel technological advantage. It's very classic measure also in international trade. It is here as a dummy variable, so it will be 1 or 0, and it's compare the ratio that a certain technology represents in a region over the total share in the whole European Union. So basically, if the share of patents that a region has, let's say in technology A, is higher than the same share counting all patents in the European Union, or higher or equal than 1, then I will say, okay, that region is specialized in that technology. If the ratio is lower than 1, then the RTA will be 0, and I say, okay, that region is not really specialized into that technology. And then by exploiting the change between the 0 and 1, you can define entry into a new technology. It's the proxy for technological diversification. So a region will have an entry if in period t minus 1 was not specialized in a technology, so has an RTA lower than 1, but in period t, it has an RTA higher or equal than 1. So I was not specialized in the previous period, and then in the next period, I become specialized. Then I can say that a region actually got specialized and technological diversified between t minus 1 and t. This is the way we define the technological portfolio and the technological diversification of regions. And this will be the entry, which is a dummy, and will have implication for the empirical strategy or the econometric setting that I will explain, is a dummy variable.
So, just to make it clear,
Yeah.
diversifying for you is specializing.
In a technology that was not present in the territory before. So, specializing into something that was not present in the territory. Then, as I said, there is a strong literature emphasizing the role of local capabilities. And it's also part of this research to understand, okay, what is the interaction between local capabilities and non-local capabilities. And particularly, here we use a measure, first of all, relatedness, because I want to see how two different technologies are related. Here we use the César Hidalgo and Ricardo Hausmann approach, definition of relatedness, and based on the relatedness, the relatedness density. Basically, and to put it simple, the relatedness between two technologies follows a logic, let's say, related to YouTube or Amazon kind of algorithm. Basically, when you watch a video in YouTube, you get then the recommendation of new videos. No? You might be interested in also watching these videos. Or if you buy something in Amazon, you get also recommendation of new products. So say, okay, you just bought a book, then you want maybe to buy this new pen. This is the way Amazon and YouTube came up with this suggestion is based on previous experience of user. So what they look is at the co-occurrence of buying pairs of goods. So if people repeatedly bought two products, they can infer that there's something between them. So people that like this kind of video, they also like the other one, because people watch them together. And that's how they define technology, or they define relatedness. Here for technologies, we look at the, you have a question? We look at the co-occurrence of RTAs of technologies. If two technologies usually appear together in the territory across years, we might imply that there is a relationship between them. If regions are repeatedly specialized in pair of technologies, we might infer how related those technologies are. Yeah?
Yeah, so in equation 5,
yeah.
like why is that asymmetric? Why aren't those two arguments the same thing? Like, that P, how do you compute that from?
Sorry, say it again, I cannot listen.
How do you compute the arguments of equation 5?
So it basically is the minimum between the conditional probabilities that you are specialized in technology I if you are specialized in technology G, or the other way around.
Right, but how do you compute those conditional probabilities?
Basically on the co-occurrence, like the repeated RTA over time. So if a region...
No, but like, I mean, those should be, I mean, depending on how you do this, I don't see how you can get something asymmetric.
No, because, I mean,
And
based on I,
You want to say
I
something?
mean, based on I you can have X, or based on X you can have I.
Right.
That's the symmetry.
No, I understand that conceptually, but the question is empirically, how in those two directions, how are you able to isolate those two transitional probabilities?
I can send you, if you want, the reference and the full paper, which I have more explanation in detail about that. Yeah. And based on that, and based on how related two different technologies are, you can just compute what we call usually the related net density, which is a very simple measure. It's nothing more than the percentage of related technologies to the focal one you want to enter that you are already specialized. Meaning that if you are specialized in more related technologies, it will be easier to you to actually enter this new technology, which is again a very quite a standard metric, at least in the field of economic geography or economic complexity. And what you expect is the higher is the related net density, the easier or the higher will be the probability of entering a new technology, because I was saying, if you already master related technologies, it will be to you easier to actually move into new kind of things. We compute this using time windows, as well as here, when I refer to T, I refer to time windows, because the RTAs and the quantity of patents produced in each year varies across years. And so we don't want the RTAs just to flip from one year to other, we want to actually stabilize them. So that's why we use time windows. In this case, we use 4 different time windows. And particularly for the case of the entry that I mentioned before, by definition, you cannot have any entry in the first period, because it's the change between t and t plus 1. So in the first period, you can actually not compare what you had before. So the entries will just start from 2001. This is the metric for local capabilities and related net density. And you can plot, this case is the average of the related net density across all technologies and across all the 4 periods. So it's very aggregated. But I just wanted to show it because it can give you a sense of how local capabilities are concentrated in Europe. And what you see is a very classic kind of core periphery distribution in Europe, which you have like countries like, or parts of country like north of Italy, Belgium, some parts of Germany, particularly industrial one, also in France. You have the East and the Ile-de-France. Here in Spain you have Madrid, Basque Country, Catalonia, the Comunidad Valenciana. So this is again very aggregated, and it's just an average across many different technologies and many different time periods. But just to give you an impression that technological capabilities based on patents are really concentrated in Spain. And you have many other regions like in the east of Europe and south, like Greece, south of Italy, and some regions in Spain and Portugal that are really struggling or having not that strong capabilities that can help to actually trigger technological change.
Well, we don't really know, right? I mean, those are numbers whose interpretation of which is impossible.
Well, I'm just following the literature in the field. Like,
right. But what does yellow mean?
So that you have a related density between 1.9 and 1.64.
What does 1.64 mean?
It's a percentage. It's the percentage of related technologies in which you are already specialized.
And is that low or high?
It's from 0 to 100, you say.
I don't know.
I mean, the maximum is 41. 1.9, I would say, is low in comparison.
Percentile 1.
Yeah, I would say.
Okay.
So it's a matter of comparison. Again, it's a very aggregated, and it's the average of many different things.
Right.
Because you have this information by time window, by technology,
That's fine.
and here just aggregate. Just to make a point that technological capabilities really start. All this idea about innovation concentrate might be hinterbases.
I mean, if your idea is to say that if you're far from the frontier then you're somehow lagging behind or something
I-
like that, then,
yeah.
then the plot should be in percentiles relative to the max, not absolute numbers.
Yeah. Yeah, I mean, to be fair, like, again, this is very aggregated and it's not the most informative kind of map, just to give a sense of what you get. What you get is like you have regions that are really specialized in many different things, and for them it might be easier to enter a new one because you have already a lot of diversity in your region. And then there is a lot of regional heterogeneity in that sense. So that was more the point I want to make. This very well. Yeah. So I was saying, we want to actually help a little bit those regions that may lack some local capabilities and then can benefit a little bit more from non-local capabilities. And that's when the value change part of the story came in place. We compute following all the classic kind of Leontief inverse matrix and so on, the domestic value added and the foreign value added of regions. So then we can compute the total global value chain participation, which is composed by the sum of the backward participation and the forward participation. The backward participation is basically the ratio between the foreign value added that I import from other regions over the gross export I produce. While the forward participation is the share of domestic value added produced in one region and that will be used in other regions' export over my own gross export. So then you can get a sense, okay, the total participation will be on this trade of foreign value added that I incorporate and the domestic value added I produce in relation with my gross export. But then you can actually put it separately between backward and forward to see if actually what you do is mainly importing value added from others to produce your export, or maybe produce domestic value added to be used for other regions in the export.
Sorry, by
Yeah.
foreign value added, you mean?
Domestic value added produced by other regions that I import to my own region. So if you have a region, let's say Catalonia, the value added that is imported for other regions and Catalonia will use in their own gross export.
I'm confused as to why that would be value added of my region, that's inputs I use for
I know,
value added.
that's right. I'm not saying that this is domestic. It's actually foreign value added that I incorporate into my region. But it has to be nothing to do. But I use the share, that quantity of my gross export in actually to see how this relationship is. Again, this is a quite a standard metric. It's the OECD one, use one, also in the TIVA kind of value added metrics is the one used. So again, we are not trying to reinvent the wheel. We are just following the literature in that sense.
And how do you calculate this?
Yeah.
Or do you calculate them? Or?
We do it using the interregional input-output table in the UE. So it's again very classic and all the stuff, going back to Leontief inverse and so on, looking to see the flow between regions. And we compute this for every region, every year. And then we can take the average, again, for the time windows, because we don't want to.
But these input-output tables are for Europe, right?
Yeah, that's for
So it's kind of assuming that all the countries use the same technology.
No, this is about trade. So this is about.
Yeah, but I mean, for example, take the foreign value added.
Yeah.
So that's out of all the imports into, say, Catalonia, right? Well, the ones that have been produced by other countries. So you should have, one should apply the input-output tables of that country.
Yeah.
By the input-output tables, I understand that they're the same for all of them.
Yeah, that's right.
Yeah.
That's the effort they're doing. Again, it has some limitation, I was saying. That's why, but it's a good point. What I also know is that, there also, we were talking before about different options that you have on Figaro, developed by the European Commission. TIVA is at national level. So the problem here is the regional dimension. If you want to explore more granularity of data, so more years and different sectors, this is better done at the country level. At the regional level, it's much more difficult. But I was in touch with colleagues in the CBS in the Netherlands, and now they are also updating the tables. So it will happen soon that we have better data. But yeah, what you have is actually flows that you can compute the value added between different industries and regions. So based on this, we compute these different three components: the total value chain participation, backward and forward. Again, I plot it, and again, it's very aggregated because it's an average for 4 different time windows. So the point I wanted to make here is that there is a lot of heterogeneity. Not just in the total participation of regions in global value chains, but also when you compare backward and forward participation. This is the backward, and this is the forward. As you see, the forward wants to be more like, or seems to be more kind of core periphery, because forward is about, again, domestic value added that regions produce and are used for others. So this is probably the case, let's say, of Catalonia, north of Italy, again, Germany, France, and this kind of regions. While others are more, let's say, importing, like for example in the east or the south of Italy. Also, forward participation, you get some agricultural regions, of course, because agricultural products are basically produced domestically. That's why you actually produce it in your own region and then you export to other places. So again, the point here is that there is a lot of heterogeneity in the ways regions participate in global value chains and in the total engagement that regions have in the value chains.
Sorry, to stop this time.
Yeah.
If we go back 2 slides. Yeah, so you're showing us component 1 of equation 7 and component 2.
Right. So the first map is the total, so it's the sum of both. Right. The first component is this one, the second component is this one. But again, just to have a little bit of visual kind of things of what's going on. So with all these ingredients, I just implement a simple linear or two-way linear probability model, again because our dependent variables is a dummy. I personally, yeah?
I mean, everything is endogenous to everything else, right?
Sorry?
Everything is endogenous to everything else.
Yeah.
Are you an instrument this?
No, I'm not using any instrument. I'm just using two-way linear probability model. I have some robustness check using also logit and probit, and also trying to actually differentiate or create a new global value chains metric.
Then, I mean,
I'm not claiming any causality in any case, right? I'm just claiming some correlation between the variables. So in any case, I didn't mention the word causal relationship or causality in this.
No, but you had some hypotheses.
Yeah.
And then, I mean, the direction of causality is going to be impossible to determine.
I'm not claiming any kind of causality. I want to be really clear on this point. I'm just talking about correlation between the variables. So then I use these two models. First of all, I regress the entry on related density and total value chain participation, and then break the total value chain participation into backward and forward participation. And then I will expand also this model interacting the value chain participation with the related density if there is somehow any dynamic happening between two variables. Of course, we use standard errors cluster at the regional level and lag some variables at mean center. So let's have a look to the results I get. I don't know if you can see it from the back. But as expected, pointed out by the literature, the related density is positive and significantly correlated with the entry. So meaning that the more technologies that are related to the one you want to enter, you are already specialized on, the more likely is that you can actually enter the technology. Then we have the total participation, which is also positive and significant, hinting somehow that there is a positive correlation between participation value chain and entry. And then you have the interaction between them, also positive and significant. But as I was saying, this is just total participation. You don't really know what is going on, the different ways you might participate in the value chain. So that's why we wanted to break it down into backward and forward. What we see here is, okay, obviously related density is positive and significant across different specifications. The other one that is positive and significant is the backward participation. So again, it was more kind of in line what I was thinking before. Like it's about importing value added from other regions, which actually might be associated with more chances of technological diversification. The forward participation, although always positive, is not significant. And what is interesting, something related to the comment before, is that when you see the interacting effect between related density and backward and forward, what you have the effect is for forward participation. So it makes be the sense that when it goes to actually producing stuff and actually exporting that value added for other regions to be used, then it really matters to actually combine with a strong local capability. Yeah.
I think you have also a kind, especially when you export, a strong self-selection problem maybe.
Yeah.
Like if you introduce lags in the dependent variable, like this would reach probably, maybe you will have more significant
On the forward.
because then you will control this self-selection.
I can check about that one.
This is mainly it's
Cool. Thank you. So, as I was saying, what I also try to do is I check for different specification. I also include the logit and the probit specification. And some concern that you may get is that, okay, the global value chain participation is computed using 14 different industries, and some industry like financial intermediation or hotels and restaurants might not really link with patents or technological knowledge. So then I compute the same global value chain participation index restricted to manufacturing and construction, like civil engineering kind of industries, to make sure that those industries are really the ones that can be actually patented or have knowledge that can be translated into patents. And the results are the same, even get more significance, both in size and statistical significance. I want also to check if there are differences across regions. So basically, if regions might benefit more from global value chains depending on the level of economic development. So I do some sampling of the full sample differentiated in 3 different categories, which is the same categories that the European Commission used for EU cohesion policy, which differentiate between less developed regions, which are the ones that have a GDP per capita lower than 75% of the EU average, transition region, GDP per capita between 75 and 90% of the EU average, and more developed regions, which is the GDP per capita higher than the 90% of the EU average. And what I find is that it's actually transition region, which the result of mine, because they are basically the same I showed before in sense of significance and also size, that are the transition regions that are actually driving these results. Maybe hinting that these transition regions are in an intermediate developing stage in which, okay, they have already some local capabilities in which they can build new capabilities coming from the value chain, but they don't have many strong capabilities than more developed regions that can per se trigger the technological knowledge. So that may be the case.
It would be very interesting. It would be like a nice addition. Your entry variable is conditional to an initial state. What if you make the variable not conditional?
What do you mean?
I mean, I forgot like the 2 components of the variable. Like,
yeah,
you said that you were not specialized because
right.
you.
The RTA, like the balance index.
Here you're trying to control like this self-selection, like assuming that you are not inside. But what happens if you, in this RTA lower than 1?
Yeah.
What would happen if you ignore this and just focus on the other side?
Like how can you define entry then?
That's the point. It would be another variable, but
yeah,
you will have a continuous variable you can control for.
You can base just the RTA like on that. Yeah, that can be something that can be done.
To complement the.
Yeah, when we don't use the dummy variable but use the continuous variable, we also try to see if there is some kind of reinforcement in the specialization. Then it's not the change into a new thing, but okay, you might be specialized in something. Do you become more specialized in whatever you are already doing or not? That can be something. That's a good point. That can be something that can be done. Yeah, so I was saying these are the transition regions driving these results. Just to wrap up and to conclude, so what kind of see from here is that, okay, there is a positive correlation between total value chain participation and the chances or probability of having regional technological diversification. It is mainly backward and not the forward participation which is driving this. However, when combined with local related capabilities, is forward participation, it's shown that it's when it's mattering. And that these interregional global value chain linkages might be more important for transition regions rather than for less or more developed regions. So by doing this, we want to integrate these 2 strands of the literature. That is a hot debate now in the literature, in economic geography and regional science, trying to emphasize the importance of value chain linkages as a source of non-local capabilities, and still highlighting local capabilities. So trying to see that we have to get the complete picture of it by including these kind of things. Of course, we have several limitations. For example, the short period of time, we're talking about technological change, technological diversification, we're just looking at 11 years, so maybe not sufficient in a way. Also, we are lacking the role of regional institutions, maybe somehow more related to what Andrés Rodríguez and these people from London School of Economics has been pointing out, and also some dark sides of global value chain participation, like for example, not just economic dark side, but also like in terms of social rights, polluting and these kind of things that is also highly important in a way. Let me just conclude, mention some particular policy implications, particularly when it comes to smart specialization strategies. Because now, again, in the strategies of regions, of industry and innovation policy, they are just looking to themselves, which is fine, and it's already a first step to have these smart kind of policies based on what you already have in the regions, but we are not exploiting this interregional dimension, which is lacking. So our point here will be that we have to make regions to collaborate between them, and as we are doing, for example, in terms of research, for example, it might be also good in terms of industry and trade in this sense. And this is not already exploited in a smart specialization framework. So that will be all from my side. Thank you very much.
I have one comment related with the database that you are using. So you are using a database that finishes at 2010,
right.
And this is a limitation, or can be a limitation. So in the Joint Research Center in Sevilla, they are using the Romulo model, and linked with the Romulo model, they are already using a database with the regional NACS2 detail, and it's an interregional database, not still public, but maybe you can use this database in the future.
Do you know the time coverage they have?
The time coverage, I think it finishes at 2018.
Okay, that will be much better.
Yes.
Yeah, indeed. Yeah. Absolutely. That's a great comment. Thank you very much.
Yeah, and another comment is that you are using the information for each country of global value participation aggregated. But what if you use a sectoral indicator? So have you thought in splitting up this?
I didn't look at this in this case, actually. That's a good point. What I did is to compute to the regions, as I said, no, using all sector or just restricting the sector, but not just, let's say GVC participation in manufacturing of gold products, whatever.
Because sectors are very different in terms of technological diversification, so maybe your results are somehow different or not.
No, in any case, what I will find out is which are the sectors that are driving this kind of results. And in any case, I mean, it's something we can try, and I'm not scared of doing this in the sense that I already compute the value chain participation based on manufacturing sector, which are the ones that you expect. So it will be a step forward in a way to actually check which industries actually driving this.
Because in the input-output table that you are using, you have many information, and you are just aggregating, so you can use this information.
And I already, I have those indicators by sector already, so it will be just a matter of sitting down and I can check it. Maybe in the train back to Seville today, I can check it.
Okay, and thank you for your presentation, very clear and very nice.
Thank you for this. Thank you.